The SR-71 Blackbird, in the opinion of many, the greatest airplane ever made. Its two huge jet engines have the power of 45 diesel locomotives. It can fly from Los Angeles to New York in under an hour, at speeds faster than a bullet. The Blackbird, designed in the early 60s, is the crowning glory of one of the greatest eras of technological change in the history of mankind. The jet age. The term was synonymous with scientific and social progress in the 50s and early 60s. The jet age conjured up not just a technological revolution, but a radical change in the way human beings thought, acted, and lived. And the jet age was powered by this. The blast of hot gases out of the end of a metal tube, one of the simplest ideas for an engine in history. Any child who's ever blown up a balloon, then released it to zoom through the air as it deflates, has seen how jet power works. The most common form of jet engine today is the turbojet. It uses spinning compressor wheels at the front end of the engine to compress the incoming air. The air is then mixed with fuel and ignited. The blast of exhaust gases out the back propels the engine forward, as well as rotating turbine wheels at the back, which turn the front compressor wheels on the same shaft. Today's jet engine was a logical progression from a device called a turbo supercharger that was first used in the waning years of World War I to get more power out of military airplanes powered by piston engines.
Here was a case where technologists were trying to allow the piston engine to breathe, if you will, more efficiently at high altitude.
With a turbine in the exhaust that rotated a compressor wheel to force-feed air into the engine, they had the main elements of a jet engine, although they didn't realize it at the time.
Ironically, for all their insight in developing these turbines, which had to operate in a very high-temperature exhaust environment, for all that insight, they missed the significance of directly connecting the turbine to the compressor.
Propeller-driven piston-powered aircraft had a built-in speed limitation because propeller blades lose sound. In the early 1930s, a few far-sighted aircraft engineers in Britain, Germany, France, and Italy began toying with the idea of eliminating the piston engine and the propeller altogether. It might be possible, they thought, to power a plane with a device not all that different from a turbo supercharger, but bigger and more powerful. Critics, however, warned it was folly to try to use a pure jet engine to power an airplane. The scoffers said such a jet engine would have to be so big and heavy the plane could never get off the ground. Some claimed the jet engine would have to be lined with bricks to protect the fuselage and the pilot from the intense heat. But a few young scientists persisted. One of them was Britain's Frank Whittle, who first wrote about the idea of jet aircraft in 1928, when as a cadet at Cranwell Military School he turned in a thesis on the possibilities of powering airplanes with a gas turbine engine or turbojet. After graduation from Cambridge University, Whittle began putting together a demonstration turbojet. His first model ran so erratically it almost exploded, and it would be 3.5 years before he had a working model, but it was too weak to power an airplane. Whittle had been given unusual treatment by the Royal Air Force. He was placed in selected positions so that he could continue to develop his radical ideas.
The irony of it is that when it came time to really back his ideas, the British government backed away from it. He didn't get the support that he needed.
Whittle had no way of knowing that at the same time in Germany, another bright young engineer was working on exactly the same idea. Hans von Ohain had convinced one of Germany's leading airplane manufacturers, Ernst Heinkel, to let him build an experimental turbojet in 1936. Within a year, he had a viable engine. And in August of 1939, the Heinkel HE-178 rolled down the runway and lifted into the sky. The world was about to change. The first jet engine was in the air. Germany was not about to announce to the world that it had just created the first turbojet airplane. The German Air Ministry recognized that they had a potential wonder weapon, and they also realized they would be at war very soon. In September of 1939, less than a month after the test flight of the world's first jet fighter, Germany invaded Poland. The war was on. But the work on getting a jet fighter into mass production still proceeded slowly. In 1939 and 40, there was no great impetus in Germany to develop the jet engine. The Luftwaffe felt invincible, and their propeller-driven aircraft were doing just fine.
In early 1940, they destroy the Low Countries and the Scandinavian countries, and then they're threatening Great Britain. And what happens? In the late summer and the fall of 1940, Germany loses the Battle of Britain. Now, that is the moment when you start seeing a stimulus. Now they suddenly realize we need something else.
Although Ernst Heinkel had flown the first jet-powered test plane, he was now in a race with his arch-rival, Willy Messerschmitt, to develop the first mass-production jet fighter for the Luftwaffe. In April of 1941, Heinkel was the first into the air with his fighter prototype, the innovative HE-280. But a year later, his competitor Messerschmitt had an even better jet fighter, the Me-262.
The 262 was a superior airplane, had higher speed, higher range, better armament package, so it was selected for production.
It was designed basically to destroy American bombers. It could do that very well because it had a tremendous speed advantage over them. It had a tremendously powerful cannon armament to do that.
17 Me-262s were ordered for tests and evaluation. When Nazi air ace Adolf Galland came to Messerschmitt's test center to fly one, he was amazed at its effortless power and speed, which far surpassed the performance of the Luftwaffe's piston engine planes.
Accompanied by only a whistling sound, my jet shot through the air. This is not a step forward, this is a leap. It will guarantee us an unbelievable advantage, so long as the enemy sticks to piston propulsion.
Meanwhile, in England, Rolls-Royce had taken over development of Frank Whittle's turbojet, and together with the Gloucester Aircraft Company, they created the Gloucester Meteor twin-engine fighter, which had its first test flight in March of 1943. But the Germans were the first to send squadrons of jet fighters into battle. 225 Me-262s were delivered to the Luftwaffe in 1944. Allied pilots would soon be shocked to see this completely new bird of prey swooping down on them at speeds that seemed impossibly fast.
I think from an Allied pilot standpoint, what they were astonished at was encountering a fighter that could put its nose up and seemingly defy gravity and simply climb vertically away from them. That came as a real shock.
U.S. fighter pilot Bob Hoover, shot down over the Mediterranean in 1944, saw his first jet from a German prison camp.
I thought, my goodness, we've lost the war, because it was going so fast. I couldn't believe that there was anything like that in existence. And I thought, boy, I might be in this place forever.
In one of the largest aerial armadas in history in March of 1945, the Allies sent 1,200 flying Fortress bombers to attack Berlin, escorted by more than 600 piston-engine fighters. The Germans scrambled 37 Me-262 jet fighters to intercept them, and the lightning-fast jets, although outnumbered nearly 50 to 1, managed to down 8 Allied bombers and 1 fighter. But the Me-262 came too late to make a difference in the war's outcome. From 1944 onwards, as the war worsened for the Nazis, German jet design began to show signs of desperation.
Some of these fighter concepts were utterly bizarre, and so you started seeing weird little fighters like the Heinkel 162, the so-called Volksjäger, built out of plywood with a jet engine on the back of the airplane behind the pilot, or the Messerschmitt 163 Comet, which was a rocket-propelled fighter that used 2 hypergolic fuels. In other words, when the fuels were mixed, they would spontaneously combust. That was actually far more dangerous to its pilots than it ever was to the Allies. You had piloted surface-to-air missiles, the Bacham Natter. You had piloted air-to-surface guided bombs. Many of these would have required years. Some of their projects would have required decades to develop.
The price of these ineffective projects was fewer effective planes like the Me-262 and the Arado 234, the world's first jet bomber. Meanwhile, the British, led by Frank Whittle, had their first jet fighter ready to go in late 1944. Called the Gloucester Meteor, it helped intercept German V-1 buzz bombs, which were powered by a pulse jet, a jet engine that took intermittent gulps of air, producing the strange sound that gave the buzz bomb its name. The British Gloucester Meteor and the German Me-262 never met in battle. The war was over before either of them could have any impact on the outcome. The U.S., lagging far behind, would not have an operational jet fighter until after the war was over. And during the war, U.S. military authorities initially had no idea how far behind they were. Aircraft engine manufacturers in the United States had shown little interest in developing jet engines. They were making millions selling piston engines to the military.
They also had very little incentive to take great, bold leaps, if you will, because of the funding that was provided by the military. The military didn't provide funding for experimental research. If they wanted to do research, they more or less had to get that money from amortizing the profits on production programs.
General Hap Arnold of the U.S. Army Air Corps arranged for the importation of Frank Whittle's jet engine technology from Britain to the United States. The General Electric Company in Lynn, Massachusetts, under conditions of great secrecy rivaling the Manhattan Project, began developing an American version of the Whittle jet. The GE engine, based in an American testbed airplane called the P-59 Aerocomet, powered the very first American jet airplane. Secret testing of the P-59 began in 1942 at Muroc Dry Lake, California, now known as Edwards Air Force Base, which was used as a training base for young pilots learning to fly piston engine fighters. To disguise the P-59, a fake wooden propeller was placed on its nose when it was moved across the base.
Pilots on the south end of the lake were not really quite certain what was going on, but every now and then some would return to base with stories of an absolutely incredible encounter. They would be flying along and all of a sudden an airplane would fly alongside with no propeller on it whatsoever.
They were probably even a little more disturbed when they peered up into the cockpit and saw what appeared to be a gorilla wearing a derby hat and waving a stogie at them.
Well, that gorilla wearing the derby and smoking the stogie was Bell's chief test pilot, Jack Willems. Jack decided that it would be a thrill enough to fly a jet alongside them, but he'd go one better. Went down to Hollywood, got a gorilla suit, got the stogie, got the derby, and he was off and running.
And apparently, the shrinks here on base managed to convince these guys that they had not seen what in fact they had seen. Because after all, everybody knows an airplane can't fly without a propeller.
Jack Willems would later lose his life in 1946 in the crash of a plane he was preparing for an air race. But the P-59 that Willems helped test would pave the way for an exciting new generation of U.S. aircraft. As testing of the very first U.S. jet continued at Muroc Dry Lake in California, it became evident that it was too slow to be the airplane the military was hoping for.
The P-59 would have been a very comfortable, nice propeller-driven fighter. What it is it's basically a piston engine propeller fighter without the piston engine, without the propeller, and with two jet engines buried in the wing roots. It had very little combat potential, but it was a tremendous learning tool.
Completely unaware of the top-secret P-59 program, Kelly Johnson of Lockheed went to the U.S. military with a plan for a radically different jet aircraft. Willis Hawkins was a young airplane designer working for Kelly Johnson at the time.
Finally, a senior colonel asked him to come into his office, and he said, first thing, you got to shut up about that airplane of yours. Secondly, we've got a twin-engined airplane that's flying today, jet engine, and it's no damn good. He said, if we give you a specification for an engine that's already running, will you go home and make us a proposal?
2 weeks later, Kelly Johnson submitted his unique proposal. And 3 weeks later, he had a contract to build America's first operational jet fighter, the P-80. It was the beginning of Lockheed's top-secret Skunk Works division, the advanced aircraft unit that would go on to build many legendary airplanes, including most recently, the Stealth Fighter.
He was given a contract to conduct at Lockheed virtually an experiment in not only in the aircraft but in production. He demanded and received authority to have a sequestered workplace, to have no government interference, to be able to do a minimum of paperwork.
Starting with the P-80 program, one of Kelly Johnson's rules at the Skunk Works was never to separate the engineering department from the manufacturing department. Willis Hawkins saw the value of that rule when he was in the office of one of the F-80's designers, Irv Culver. The manufacturing department on the floor below called up to say they needed a part designed to brace a small curved section of the bulkhead.
Well, Irv said, let's go down to the shop. And he took a piece of cardboard and fiddled with it and cut it with scissors until it fit, bent up the edges, and he said, make it like that out of 060 aluminum. And the guy said, fine. And Culver said, bring it back, I gotta make a drawing of it. And that was what was meant by the communication with the shop.
The all-new P-80 could fly at 560 miles an hour, about 150 miles an hour faster than the P-59. Bob Hoover, who saw his first jet from a German prison camp, was now a test pilot in the P-80 program, contending with early jet engines that after 5 hours would overheat and malfunction.
Those days we didn't have ejection seats, and you knew you had to get it on the ground quickly or you were in a lot of trouble, because if the front light came on, that meant it's going to blow up pretty quick.
In the world of fighter aircraft, models like the P-80 were designated P for pursuit. That changed in 1948 when the P became an F for fighter, as in F-80. The F-80 Shooting Star became America's first production jet fighter in 1944. It led to the more advanced and powerful F-84 Thunderjet in 1946. It was the first U.S. jet to have an ejection seat, an idea that was copied from the Germans. Bob Hoover was the first to use one in an emergency, or at least try to use one. It happened when the jet engine on his test plane suddenly malfunctioned.
It's very abrupt when one of those jet engines freezes. That whole airplane lurches like that. And now it's just pitching over and I'm completely out of control. And so I thought, well, here we go with this seat. And so I reached down and pulled the handle and nothing happened. Then I opened the canopy and was sucked right out. And the reason for the ejection seat is to get you over the tail to avoid killing the pilot by hitting the tail. I went right into the tail and broke both legs right through the knees and landed way up in the Antelope Valley there.
Near death from shock and exposure, Hoover was eventually picked up by a farmer who saw his parachute in the sky and searched for the downed pilot for hours.
The move into a jet fighter was a very pleasant experience.
Marty Knudsen logged more than 1,000 hours as an F-80 pilot in Korea after first flying a piston engine fighter.
Suddenly you didn't have to worry about having the right RPM for the power you were pulling and the mixtures. There was none of those controls. You had a go handle. It was either off or fast.
But American jet pilots soon faced a formidable opponent in Korea.
In November of 1950, an airplane appeared which absolutely shocked us, the MiG-15. It was a Russian-built airplane powered by a derivative of the Rolls-Royce engine, which England, either through stupidity or somebody's treasonous effort, had sold to the Soviet Union at a time when it was very, very foolish to have done so. It gave the Soviet Union engine industry a massive injection of technology.
Immediately, the whole stakes in the air superiority battle changed. The F-80 was not really suitable to duke it out with the MiG-15. It simply had too many performance problems relative to the higher performance MiG.
The North American F-86 Sabre jet, which arrived later in the Korean conflict, came close to matching the Soviet MiG-15 in performance. Aircraft designers were playing catch-up with the dramatically higher speed capabilities of jet engines. The F-86 was the first U.S. jet to have its wings swept back at an angle, like the MiG-15s, which created better handling at high speeds. The F-86 wasn't quite as fast as the MiG-15, but flown by the better-trained U.S. pilots, the F-86s were just enough to redress the balance in Korea. In the early days, jet development and rocket development were closely related, and both were used to power experimental airplanes. The main difference between the two is that the jet engine uses oxygen in the air for its combustion, while the rocket carries oxygen on board for its combustion. That makes the rocket engine heavier, but allows it to operate outside the Earth's atmosphere.
People made very little distinction between them. Both were referred to as jet propulsion. The Jet Propulsion Laboratory, for example, when it was set up, was a laboratory to investigate largely rockets. There was this feeding process back and forth between the two.
In October of 1947 at Edwards Air Force Base, Chuck Yeager in the rocket-powered X-1 did something many had predicted would never be done. He flew an airplane faster than the speed of sound. His chase pilot on the historic flight was his good friend, Bob Hoover.
Oh, it was considered absolutely impossible. There was a wall of resistance that no one could penetrate.
With Yeager at the controls flying at nearly 700 miles an hour at 23,000 feet, the rocket-propelled Bell X-1 became the world's first supersonic airplane. But jet engines soon proved they were just as capable as rockets of breaking the sound barrier. In 1953, the North American YF-100 became the first jet fighter to break the sound barrier in level flight. It was powered by the highly successful and versatile J-57 jet engine made by Pratt & Whitney, which had become the second U.S. manufacturer of jet engines along with General Electric. The Cold War of the 1950s brought a mood of fear and suspicion, and the jet engine found a new application in a super-secret spy plane called the U-2. It all started when the CIA came to Kelly Johnson at the Skunk Works with an idea.
All the CIA said to Kelly was, we want something that goes a long way and gets very high, and we want pictures of you-know-who.
Marty Knudsen was one of the first 6 Air Force pilots recruited by the CIA to fly the mystery aircraft.
We were asked if we'd be interested in flying on a very dangerous mission that would be of great value to the United States of America. And any red-blooded young man says yes to that, you know.
Some of the pilots speculated their secret mission might be to fly the first spacecraft. Marty Knudsen hoped it might be a new Mach 2 supersonic fighter. The 6 young fighter pilots were shocked when they were taken to a remote CIA airfield and shown the ugly duckling they were going to be flying.
It didn't really look like my cup of tea, being a young hot fighter pilot, seeing this big, long, gangly wing thing sitting there.
It may not have been pretty, but it was a jet, whose specially modified engine would propel it to incredible heights.
We immediately started flying the airplane the next day and being told to start laying down operational plans for missions over Russia.
Flying the U-2 was unlike anything Marty Knudsen had ever experienced as a pilot.
You're almost like you're living in another world. You can just start to see the curvature of the Earth. Well, I guess I should say it's a big ego trip to sit up there 70,000 feet and look down at that man's puny effort and the world below you.
The U-2 was also powered by Pratt & Whitney's popular J-57 engine. But to allow operation at 70,000 feet and higher, the engine had to be virtually hand-built, with much closer tolerances to minimize loss of air pressure at high altitudes. It was believed the U-2 could fly with impunity over the Soviet Union because no Soviet fighters or missiles could go high enough to shoot it down. and at first, that was true. The apparent invincibility of the U-2 lasted until May 1st, 1960. The day U-2 pilot Francis Gary Powers took off on a fateful mission over the Soviet Union.
I was at Buda, Norway, where he was supposed to land, and I was supposed to take the airplane off on its next flight out of there. I started pre-breathing oxygen to fly, which you need to do 2 hours before takeoff, and of course he never arrived.
Powers had been shot down by a Russian missile and captured. He was sentenced to 10 years in a labor camp, but was released 2 years later in a spy exchange. The U.S. announced an end to the Soviet overflights, but the U-2 continued to fly. Exactly where is still classified. Perhaps the most amazing thing about the U-2 is that it is still flying on reconnaissance missions for the Air Force and research missions for NASA.
We started to see a shift in aircraft development. Aircraft which had been designed for months of service or several years of service, now we started to see the potentiality of aircraft serving for decades of service.
The U-2 isn't the only legendary Cold War jet still flying. The B-52 bomber has been in service since 1955, and like the U-2, was invaluable in the Persian Gulf in the 1990s. The B-52 was yet another landmark U.S. aircraft powered by Pratt & Whitney's J-57 engine, the engine that won the coveted Collier Trophy for aviation design. The B-52 had 8 J-57 engines hanging in double pods below its huge drooping wings. They enabled the world's largest jet bomber to cruise at more than 600 miles per hour and drop its bombs from 8 miles up, beyond the reach of anti-aircraft fire. Walter Boyne flew B-52s as an Air Force pilot in Vietnam.
When you have complete air superiority, you could send over a dump truck and drop bombs from it, and essentially that's what the B-52 does. But no one of it would ever anticipated that the airplane would have been flying in 1999 or as it probably will be in 2019.
In the Gulf War, the B-52 had 2 roles. In the longest bomber flights ever undertaken, the huge planes would fly non-stop for 35 hours from U.S. air bases to release their cruise missiles and to drop conventional bombs on ground troops as they had done in Vietnam. B-52 attacks were devastating. A single plane able to carry 80 bombs weighing a total of 75,000 pounds.
The B-52 will fly well into the 21st century and possibly even in re-engined variations where we replace the 8 jet engines on the airplane perhaps with 4. As the capabilities of the jet engine change, we realize now that airplanes in many ways are like vessels. We can re-engine them, we can repackage them, we can, if you will, reinvent them.
Venice, California. In the early 1950s, it was known as a breeding ground for the Beat Generation, a gathering place for folk singers, jazz musicians, poets, and contrary thinkers. Roy Marquardt, a Venice resident, wasn't a beatnik, but he was a contrary thinker. While everyone else in aviation was getting excited about the new turbojet engines, Marquardt had a passionate interest in a radically different, much simpler jet engine, the ramjet.
We were always told that Roy's first ramjet was made on a curb down in Venice, California, taking a hammer and some sheet metal and making a cylinder in which he could burn this the air and the kerosene or whatever.
Sometimes called the flying stovepipe, the ramjet is a metal tube with no moving parts. It works only at extremely high air speeds, high enough for the speed alone to compress air in the front part of the engine, where it's combined with fuel and ignited.
The air is brought in to the inlet of the engine. In this area here we have the fuel control system, which controls the operation of the ramjet itself.
Instead of a compressor in the front like the turbojet, the ramjet's high speed alone creates the air compression required. The ramjet was first used in an operational jet aircraft in 1962 when the CIA began flying a revolutionary new spy plane made by the Lockheed Skunk Works, the huge, graceful SR-71 Blackbird. Because of its stunning appearance and astounding capabilities, many still regard it today as the ultimate jet. These huge engines used a combination of turbojet and ramjet propulsion to power the SR-71 to 3 times the speed of sound. Mythical, almost magical to those who knew it, and especially those who flew it, the now retired Blackbird flew faster and higher than any U.S. jet has to this day. At least that's the official story, although some speculate there may be even faster spy planes today that we aren't being told about. The Blackbird began when the CIA brought a major design challenge to Kelly Johnson Skunk Works. They wanted a replacement for the U-2, which flew extremely high but was slow and therefore too easy to shoot down. The Skunk Works came up with a plane that could fly much faster, at 3 times the speed of sound, and even higher at altitudes approaching 100,000 feet.
One of the strongest deterrents that perhaps we had for aggressors all through the Cold War was that notion of the would-be despot or actual despot sitting down enjoying his cup of coffee or whatever, and then hearing that boom and realizing that he had just been overflown.
In the early 1950s, it was a commonly held view that while jet propulsion might make sense for military planes, the jet was impractical for use on passenger aircraft. For one thing, the jet was seen as a fuel guzzler and therefore not economically feasible for commercial travel. But that overlooked the fact that the fuel it guzzled was cheap kerosene, not the highly refined, expensive aviation fuel that piston aircraft were using. And there was another economy the airlines were unaware of. Because the jet engine had virtually no vibration compared to a piston engine, there was much less wear and tear on the engine and the aircraft, and the time between overhauls, or TBO, could be increased dramatically.
A lot of people think that the success of the jet age was because of the speed. The main factor was the economy. They would take the engines out and find they were just like new. And they'd put them back in again, and then they'd come back again, and they were still like new.
The time between overhauls has soared from a few hundred hours on the piston airliners of the early 1950s to more than 20,000 hours on jet airliners today. In 1952, Britain became the first country to put a commercial passenger jet into service. The de Havilland Comet was celebrated as a huge breakthrough in international travel. But success turned to tragedy. After 2 disastrous crashes, all Comets were grounded. The problem turned out to be cracks in the fuselage due to metal fatigue, which caused the pressurized cabin to eventually explode. The first passenger jet in the United States, the Boeing 707, went into service in 1958. Its design was influenced by Boeing's B-52 bomber, and it used the same engines, suspended from the wing in pods, as on the B-52. 707 was a huge improvement over any passenger plane that had ever flown.
You can say that the jet age really began when Pan American put the 707 into service, because that was the sustained service. The world never looked back after that.
From the 1950s onwards, commercial aviation stopped being the province of an elite. It stopped being the stuff of rolling as people did, red carpets out to an airplane as passengers boarded. It now became a mass means of communication and travel. In 1958, more people flew across the North Atlantic than sailed across it that year.
Within 10 years, world passenger air travel had quadrupled. There was a famous picture on the cover of Life magazine, and I think it showed 42 airplanes lined up waiting to take off at Kennedy. And it was becoming evident that the airlines, and especially the busy hub airports, were becoming congested. And the answer was a bigger airplane.
In 1970, Boeing, working in cooperation with Pan American Airways, produced what is still the biggest passenger jet ever, the gigantic 747. It was more than twice the size of a Boeing 707. The 747's 4 jet engines are so huge, you can stand inside the intakes. Today's 747 is very different from the one that came out in 1970. The engines make half as much noise, use 17% less fuel, and are more powerful. The original 1970 engines had about 20,000 horsepower at takeoff, and today's engines have about 5,000 more. It can carry more than 60,000 gallons of fuel and has a range of more than 8,000 nautical miles. That means its gas mileage is about 750 feet per gallon. The first 747s in the early 70s sold for $21 million. Today, a 747 will cost you $170 million. And you can order your choice of engines from either General Electric, Pratt & Whitney, or Rolls-Royce.
It's been the flagship of the world's airlines now for almost 30 years. So it's time for another one.
The next big development in air passenger travel will be just that, big. Airbus is developing what some are calling the Super Jumbo, a double-deck plane half as big again as a Boeing 747, and capable of carrying 600 or 700 people halfway around the world. New generation passenger jet engines being produced by GE for the Boeing 777 are the most powerful ever, reaching about 40,000 horsepower at takeoff. Nearly 30 years after Chuck Yeager broke the sound barrier, the Concorde carried the first supersonic passengers in 1976. The Concorde's 4 engines, developing about 16,000 horsepower each at takeoff, propel it to twice the speed of sound. The plane's development was paid for by the French and British governments, which helped eliminate a competing American design. Eventually, the Concorde planes were given free of charge to the respective national airlines in Britain and France. It has never been a profit-making aircraft, partly because its loud sonic boom prohibits travel over populated areas.
I call it a technical miracle, which it is, but it's an economic disaster.
Because of the sonic boom problem, many airline experts are pessimistic about the expansion of supersonic passenger travel. But $10,000 is a drop in the bucket where military air superiority is concerned, and that's where supersonic aircraft will continue to push the envelope. In recent years, the jet's more glamorous cousin, the rocket engine, has been getting all the attention. But now the jet engine is hot again. Jets combined with rockets are on the cutting edge of NASA's newest technology to take us into space. NASA believes the revolutionary new scramjet could put payloads into orbit much cheaper than the rocket-powered space shuttle. But a jet engine needs air to work, so rockets which don't need air would take over beyond the Earth's atmosphere. The scramjet is a supersonic version of the simplest type of jet engine there is, the ramjet.
Ramjet reaches a certain altitude, it becomes less efficient, and the scramjets, the supersonic combustion ramjets, become more efficient at the higher altitudes and the high Mach numbers. We're talking about Mach numbers between Mach 8 and Mach 20. This is probably the only way in the future that we're going to come up with low-cost access to space.
Another new cutting-edge development in jet engines is called thrust vectoring. It allows the jet's exhaust to be aimed instantly in any direction, creating great maneuverability. Thrust vectoring technology was pioneered in the X-31 program at the NASA Dryden Research Center in California. The highly maneuverable X-31 staged an amazing demonstration at the Paris Air Show in 1995. The Air Force's new fighter jet, the F-22 Raptor, has thrust vectoring to a limited degree. And beyond the F-22, the next generation Joint Strike Fighter that will be used by the Air Force, the Marines, and the Navy is expected to have even greater thrust vectoring capability. Eventually, some say the jet fighter will be an unmanned air vehicle, or UAV, like those being developed at the Lockheed Skunk Works by Eric Knudsen. His father, former U-2 pilot Marty Knudsen, once flew jets over the Atlantic using a handheld sextant to navigate by the stars. Eric's unmanned planes do it all with a computer chip.
Well, if I understand this right here, this is the man and more. Something like that's the pilot plus all the avionics.
Small unmanned air vehicles like this Sikorsky model will someday fly military reconnaissance missions through urban canyons and even inside buildings, and some may be powered by tiny microturbine jet engines.
The drawings and designs I've seen have engines about the diameter of a quarter or less. And we're talking about engines that are extremely small, very lightweight, and probably a few years off in the future before they come to existence.
The Skunk Works and other U.S. aircraft companies are also designing much larger unmanned vehicles that could someday fulfill the role of today's jet fighters. One of the greatest aircraft mysteries of all time is the Aurora, a top-secret U.S. spy plane rumored to be flying since the early 1990s at speeds as high as Mach 7. It's speculated the plane, if it exists, may use a highly advanced form of jet propulsion, unlike any we've seen so far. When the legendary SR-71 Blackbird was retired in 1990, many speculated the Air Force must have a new and even better spy plane. In the early 1990s, there were several sightings of a strange, loud aircraft that left an unusual contrail, described as donuts on a rope. When the mysterious budget item Aurora was included on an Air Force report, apparently by accident, the name stuck. But does the Aurora really exist?
I have to tell you that I don't know, but here's my personal opinion. I think that the Aurora existed, that it was flown, was not satisfactory and withdrawn. Now, that may be completely wrong, but that's my opinion.
That view might be supported by the fact that the United States temporarily reactivated 3 SR-71 Blackbirds in 1995. Throughout the history of the jet engine, the most mind-boggling developments have taken place in secret, only to be revealed much later to an amazed public. Today, billions of dollars are spent each year for research, development, and production in secret military programs. If the money's being put to good use, we can prepare to be amazed at any moment.